Example 1, and I thought we'd start with an example that we can verify. We have here r is equal to 5 for values of theta between 0 and pi. And when we rotate this circular arc around the initial line, we're going to get a sphere. And the surface area of a sphere is given by 4 pi r squared. The radius here is 5. So that's going to be 4 times pi times 5 squared. 5 squared is 25 times 4 is 100. So that would give us 100 pi square units. So we're going to aim to use our formula to show that the surface area of a sphere with radius 5 units is 100 pi square units. In other words, we're going to use this verification to show that this does indeed give us the surface area of such a sphere. So, in this case, we know that r is equal to 5, and that means dr d theta is equal to 0, because we're just differentiating a constant. So s is going to be the integral from 0 to pi of, now remember r is 5, so when we substitute in here, we're going to get 10 pi sine theta, and then we're going to get the square root of 5 squared. And the square root of 5 squared is just 5, so we're going to get the integral from 0 to pi of 50 pi sine theta d theta. So that's going to be negative 50 pi cos theta to be evaluated between 0 and pi, which gives us negative 50 pi cos pi take away negative 50 pi cos 0. Now cos pi is negative 1, so this first one becomes 50 pi. With the minus minus here, that becomes a plus, so we've got plus 50 pi, giving us 100 pi square units. The same answer as we got for the formula for the surface area of a sphere above.